You've worked with composite figures before. Now, in 7th grade, we're going to work with composite figures that use circles. What is a composite figure? It's just a shape that's made up of other shapes. Here we have some examples. This is a rectangle with 2 semicircles. Can you see how we've cut a circle in half here and stuck it onto the end of a rectangle? And we did the same thing over here. That's what semicircle means, half a circle. So we have 2 circle halves that have been stuck on to the end of a rectangle. So how could I find the area of this figure? Well, what we want to do is just break it into pieces. I like to outline the pieces of the shape that I'm working with and actually give them labels, like give them a name. So I've broken this shape into 3 little chunks and I'm naming them A, B, and C. So now I want to find the area of part A, the area of part B, and the area of part C. I'm going to model this one and let you do the next one with your partner. So let's look at A. I know that it is half of a circle, and I know how to find the area of a circle. I know that in order to do that, I'll need to know the radius. So I'll need to know how far it is from the center of the semicircle to the semicircle. I am given the diameter here. I'm given the distance all the way across. So if I'm going to use the formula pi r squared, that would be the area of the circle. I am going to need to first find the radius. Now you're probably thinking, Ms. Johnson, that's the formula for the area of a circle. But shape A is not a circle. It's a semicircle. And you would be right. So here's what we're going to do. We're going to take that formula for the area of a circle, and since we want just half of a circle, we're going to put 1/2 in front. Or if you don't like writing fractions like that, what you could do is you could just say pi r squared divided in half, or divided by 2. And that would be another way to accomplish the exact same goal. So that's our formula. We know our formula, but do we know our radius? Yes, we do. The diameter is 6.5. Divide that by 2, and we can find our radius. 2 goes into 6 3 times. 2 goes into 5 2 times. And 2 goes into 10 5 times. So our radius is 3.25 centimeters. So the area of this semicircle will be pi times 3.25 squared. And then we have to divide that by 2 also, because remember, we're talking about a semicircle, half of a circle. So after we use the area formula, we add one more step, we divide by 2. All right, take a minute, pause the video, do the math. Oh my goodness, that was a lot of math. Would you like to take a minute just to check your calculations? What you should have gotten is that the area of this semicircle, part A over here, is equal to 16.58312.5. Take a minute just to look at the steps and see if you can figure out if all of your calculations were correct or if maybe you went a little bit off somewhere. Now, as you look at this, something to keep in mind. In normal situations in real life, you're going to be able to use estimation. You won't have to use this many decimal places most of the time. Today, we're practicing with decimals, but in general, rounding is your friend, and it will help you make a very reasonable approximation without having to work with this many decimal places. However, today we are practicing calculations with decimals. Okay, so we know part A. Let's take a look at part B, and I'm going to clear out some space for our calculations. I hope that you are using a separate piece of paper because we don't want to get messy. All right, so that was our plan for part A. Let's make a plan for part B. This is pretty simple because it's just a rectangle, and the area of a rectangle is equal to the base multiplied by the height. So the area of part B here will just be 13 times 6.5. That's not hard at all. All right, that rectangle has an area of 84.5 centimeters. So let's put that right there, 84.5. Now, y'all, how big do you think part C is? That semicircle over on the right side? Talk with your partner for just a moment. Let me box in our plan for part B. Okay, I agree with you guys. Part C is going to be the same as A. Let me write that down. Same as A. These two semicircles are congruent because they have the same diameter. They have the same radius. So they have the same area. All right, so I'm moving our plan over to the side there because now we're ready for the final step. We have a shape that is made up of 3 different subshapes. To find its area, all we need to do is add those 3 areas together. Now, when you are adding decimals, you absolutely must line up your decimals and you must line them up perfectly. It's also a good idea to put zeros in any spaces that are empty after that decimal, just to keep everything in line and orderly. All right, let's add. Great. So here's our final area of the shape. And I'm going to write it with its units, 117.66625 centimeters squared. That's our final answer here. Now you have watched me do a lot of math. It's now your turn. So you're going to work with a partner, and your job is to find the area of the figure that you see in problem number 2. Go ahead, set a timer for 5 to 10 minutes, and let's see what you come up with. I know you're going to figure it out.